Hello friends, as we have already learned in chapter 3 the topic mean as well as median. Now today we are going to learn the third measure of central tendency in chapter 3, that is mode. What is mode and which are the methods to find mode in a raw data, in a discrete data and in a continuous data. Today we are going to solve one sum of each method as well as we will see what is mode. So let's start. What is mode? Meaning the value which gets repeated maximum number of time. Mode means the value which gets repeated maximum number of times or the value occurring with maximum frequency. That means, for example, if there is the numbers given 1, 2, 5, 5, 6, 7, so 5 is repeated twice. That means which is the value which repeats maximum number of times? So that is 5. So 5 is the mode. The value which get repeated maximum number of times, that is mode, or the value occurring with maximum frequency. If frequencies are given, then the value which is having maximum frequency can be considered as the mode. Frequency cannot be considered as the mode. The value which is having maximum frequency, that can be considered as the mode. And it is denoted by capital N and in subscript O. So MO. So what is mode? The mode is the value which gets repeated maximum number of times, or the value occurring with maximum frequency in a given data is called mode, and it is denoted by MO. Okay, this is the meaning of mode. It can be asked in one-liner or it can be asked in MCQ that it is denoted by what. So MO. And what is mode? The value which gets maximum number of time repeated. Okay, next we will see the mode in how to find mode in a raw data, in a discrete data and in a continuous data. Calculation of mode for a raw data and for a discrete frequency distribution. In this case, the mode can be found simply by inspection. That is, by looking only we can find the mode. We can find the mode as the value among the observation which is repeated maximum number of times, or the one which has maximum frequency. That means the value which is having maximum repetition. For example, what I have given you the example in the previous slide, that is, if 5 is repeated twice or thrice or 4 times, then 5 is the mode. Or if 5 is having the maximum frequency, then 5 is the mode. Let us see one example of raw data and discrete data. Here the number of books purchased, you can see in the very first illustration, the number of books purchased by each of the 15 persons from a bookstore are as follows. Okay, 1 numbers are 1, 0, double 2, that is 2, 2, 3, 4, again 2, 7, 2, 2, 5, 4, 2, 1, 2. Now here you can see that 1 is repeated twice. See, you can see 1 is repeated twice. Okay, then 0 is not repeated, 2 is repeated 1, 2, 3, 4, 5, 6, 7. 2 is repeated 7 times. Then 3 is not repeated any time, but 4 is repeated, see, twice. See, 4 is repeated 1, 2. Then again 2, then 7 is not repeated and 5 is not repeated. Here 2 is also repeated and 4 is also repeated. But which value is repeated maximum number of time, that can be taken as the mode. So for modal value we can see that 2 is repeated 7 times. We have calculated 2 is repeated 7 times, which has more number of repetition, hence mode is 2. So you have to write like this, hence mode is 2, MO equals to 2. Okay, thus the mode of number of books purchased is 2. Now again one more illustration, illustration 30. In this, TV set assembled by TV manufacturing company in the month are tested. This data is the raw data. Now this data is the discrete data, because here frequencies are given, you can see. So now in discrete data, the value which has maximum frequency can be considered as the mode. Now you can see in this data 0 is having frequency 45. If any value is there whose frequency is more than 45, then that can be considered as mode. Now 1 is having frequency 22, so no, we cannot take this. Now 2 is having frequency 18, no, we cannot take this. 3 is having frequency 10, no, we cannot take this. 4 is having frequency 6, no, we cannot take. 5 is having frequency 4, yet we cannot take. So maximum frequency is having 0. 0 value is having maximum frequency, hence MO is 0. You can see here the mode of the number of defective in the TV set is 0. Okay, so here MO equals to 0 because 0 is having maximum frequency. In this way we have solved the mode in a raw data as well as in a discrete data. Now how to solve mode in a continuous data? Let us see. For a continuous frequency distribution, when the data are converted into frequency distribution with classes, the exact value of observations are not available. Yes, when the data are converted in the frequency classes, the exact value of observations are not available. So, median for mode also, class containing mode is to be found first. First of all, our first step will be find the modal class, and then we will find the value of mode by using that modal class. Okay. Let us see one example, you will understand more. By looking to just theory, you will not be able to understand. So let us solve the example. Here, the example is given. The following table gives output of the worker in a factory. Find the modal output. That is, you have to find the mode. Here, classes you have been given. Classes is 150 to 160. 160 to 170, 170 to 180, 180 to 190, 190 to 200, 200 to 210, 210 to 220 and 220 to 230. Okay, and the frequencies are given 4, 5, 19, 33, 48, 22, 20, 12 and 6. Now first step is to find the modal class. Now you have to see from all those frequency which frequency is highest. Yes, 48 is highest. So my modal class will be 190 to 200. That is 190 to 200. Here you can see 190 to 200. So my modal class will be 190 to 200. Now let us solve. From this modal class you have to find the mode. Let's start. Taking L, for example, it is 190 to 200. My modal class is 190 to 200. So what will be my L? That is lower limit. Lower limit is 190. So we have written lower limit as 190. What is my FM? FM means the maximum value frequency. That is 48. 48 will be my FM. FM equals to 48. Now what will be my F1? F1 is the class preceding to the modal class. The frequency of the class preceding to the modal class. What is F1? The frequency of class preceding to the modal class. Here you can see modal class is this. FM is 48. So what will be my F1? the frequency preceding to the model class, that is 33. So my F1 will be 33. And now what will be my F2? My F2 will be class, a frequency of the class succeeding to the model class. So after the model class, class is 200 to 210. So my F2 will be 22. Here you can see your F1 will be 33 and F2 will be 22 and your FM is 48. See, F1 is 33, F2 is 22, and the class length, you can see your model class consists 190 to 200, so there is a difference of 10. So your class length is 10, C is equal to 10. Now what is the formula of MO? You have to learn this formula. MO equals to L plus Fm minus F1 upon 2Fm minus F1 minus F2 into C. This is the formula to find MO. Let me repeat again. L equals to Fm minus F1 upon 2Fm minus F1 minus F2 into C. This is the formula to find mode after finding the model class. Now we have already seen what is L in the model class, that is 190. So we have written here 190. Then what is F1? F1 is 48. So we will write 48. Okay. Then what is F1? F1 is 33. So we will write here 33 upon 2Fm. Fm is 48. So 2 into 48. Then F1 is 33. So here 33 and F2 is 22 into C, that is 10. Now 48 minus 33, here you have to minus this both. So 48 minus 33 is 15. Then 2 into 48 is 96. 96 minus 33 minus 22 into 10. So by doing like this, 150 into 10, 15 into 10 is 150, and by doing subtraction, 96 minus 33 minus 22, we will get 41 as the answer. So by dividing 150 by 41, we will get 3.6585. 3.6585 plus 190, we will get 193.6585. And we will do the round off of that, and then we will get the final answer, that is 193.66. So my mode is 193.66. So the modal output is 193.66. In this way, by this formula, you have to find mode in a continuous frequency distribution. So first of all, in a continuous frequency distribution, we have to find the modal class. After finding the modal class, you have to find the L, Fm, F1, F2 and C. And then you have to write the formula MO equals to L plus Fm minus F1 upon 2Fm minus F1 minus F2 into C. After that, you have to put the values and then you have to solve the sum. At the last, you will get the answer. At last, you have to write the unit. That is, here they have written items. Unit is items. So we have to write the units at the end. So in this way, we have to solve the mode in a continuous frequency distribution. But here you can see that classes are equal. That's why it's simple to find the mode by this method. But if classes are not equal, then mode cannot be found by this method. Then mode can be found by only one method, that is empirical formula. We have already studied the empirical formula in the previous topic, that is mean. In that, empirical formula was given by Carl Pearson. The empirical formula, let me remind you the empirical formula. Empirical formula, MO equals to 3M minus 2x bar. So 3M minus 2x bar is the empirical formula. If mode, if the classes, here the classes are equal, but if the classes are unequal, then you have to find mo equals to 3m minus 2x bar. So your first step will be find mean and then median, then put it in this formula 3m minus 2x bar and then find mode. So if the classes are unequal, you have to use the empirical formula given by Carl Pearson. And if the classes are equal, then by this way you have to solve the mode. Okay, I hope you have learned the mode, their meaning, and how to solve the mode. Thank you everyone.